Hey guys, welcome back, and we are going to start Unit 4. So, there's two things that you need to either print off. I did have them in, for packet pickup back in December. We had one of those. So if you cannot print these two things off, then I need for you to email me, and I can leave these at the front desk for you to come pick up at West. So it is the Geometry Notes Unit 4, Congruent Triangles, and then the Geometry Supplemental Sheets Unit 4. So let me know if you need those by emailing me to let me know that. Do not get far behind, so make sure you have printed those off or gotten them pretty quick, okay? We are going to try to get through this entire unit, so Unit 4, probably by the end of January. We're going to do 3 sections this week, 3 sections the following week, and then the last week of January, you'll only have 1 section, test, review, and test. So that should be a pretty light week in general, other than the test, of course. Okay, so this is all about triangles and congruent triangles. So congruent, remember congruent means the same. Another way to think of it is equal, but they're not, it doesn't mean the same thing. So they are congruent. They look exactly alike, okay? So first, we need to talk about a triangle. It's a polygon with 3 sides. So we have what we call obtuse triangles, where we have an angle that's at least one angle and only one angle that's more than 90 degrees. We have a right triangle that has one angle at 90 degrees. And then we have acute triangles, where all angles are less than 90. Okay? Interior angles are when the sides of a triangle are extended. The 3 original angles are the interior angles. So like this is an interior, this is an interior, and this is an interior. They are inside the triangle. Exterior is when I extend the sides. So if I think about a triangle, and you're going to extend them in kind of like a windmill fashion. So I'm going to take this line, I'm going to extend it up. This is my exterior angle. So I'm going to go from this side, I'm going to extend this down. This is my exterior angle. And then I'm going to go from here and extend it this way. This is my exterior angle. They go in a windmill, okay? It is not this angle back here, because those would always be 180. It's the other side of it, okay? The sum of the measure of the interior angles of a triangle is 180 degrees. You guys probably already know that. And then when we are talking about exterior angles, one thing I want you guys to know about exterior angles theorem, or about exterior angles, this isn't the theorem. Exterior angles always add to be 360 degrees. Okay? So they're always going to add up to be 360 degrees, the exterior angles. Okay? This theorem, though, is stating, okay, I'm going to draw another triangle. If I extend this, this is an exterior angle, so then I'm going to extend this. This is an exterior angle, so then I'm going to extend this. This is an exterior angle. What this theorem is stating is, let's just talk about this exterior angle. It doesn't matter which one I pick. So that exterior angle actually is equal to this interior plus this interior. Okay? The reason being is, if I look here, these two angles, this interior with this exterior, equal 180, right? So let's say that this interior was 40 degrees. Right in there is 40 degrees. That would make this exterior 140 degrees, because those two would have to add up to maybe 180. But then if you think about it, a triangle itself, all the interior angles add up to be 180. So it means that this angle plus this angle plus this angle would have to be 180. Well, these two angles would be that 180 minus this 40 degrees, which would be 140 also. So the exterior angle is equal to the 2 non-adjacent interior angles added together. Okay? Corollary to the triangle sum theorem is the acute angles of a right triangle are always complementary. All right. Are we good? What that is saying, right triangle. This is 90, right? They're saying this acute angle and this acute angle are complementary. Well, complementary, if we remember, there's complementary and there's supplementary. Alphabetically, C comes before S, so complementary is 90 degrees, supplementary is 180. So all this is saying is that this angle plus this angle will always equal 90. Because this angle is 90 degrees, all three add up to 180, so 180 minus this 90 leaves me with 90 degrees for those two. Okay, classifying triangles. You have to be careful on this, guys, because we classify two ways, and always two ways. Okay? We classify them by their sides. So we have a scalene triangle where no congruent sides, so none of the sides are the same length. We have isosceles, where two of the sides are the same length. And then we have equilateral, where three sides are the same length. Okay? Then, so that's the first way we classify them. The second way is by their angles. So we talked about this briefly above. So we have an acute, so all three angles are less than 90 degrees. We have a right, where one angle is 90 degrees. And then an obtuse, where one angle is more than 90 degrees, or obtuse. We also have what's called equiangular, where all angles are equal. Now, we've talked about equilateral and equiangular in the past. And if you remember that a regular triangle is both equilateral and equiangular, right? Well, if you are equilateral, then you are automatically equiangular. So if I have a triangle and all sides are equal, that actually means that all angles are also equal, and vice versa. If I have a triangle that's equiangular, all angles are equal, that actually means that it's also equilateral. Therefore, they are always regular. Okay? All right, next page. Classify the triangles by its sides and by its angles. So this one has an angle measure of 100 degrees. So that means that this is obtuse, because there's one angle that is more than 90 degrees. They have no markings for the sides, which tells me that since there's no markings, I cannot assume that any sides are the same length. So this would be scalene. Go ahead and pause me and try number 2 and 3 on your own. Unpause me when you're done to see if you're correct. So number 2, this is the picture or the symbol for a right angle. So this is a right triangle. And again, I have no markings for sides, so I cannot assume that any of them are the same length. So this is a scalene triangle also. Number 3, this is 75 and 75. So that means that that adds up to 150. That would leave 30 degrees for this angle because there's 180 degrees. All those angles are less than 90, so this is an acute triangle. I have two sides that are equal because there's a marking here, so this is an isosceles triangle. All right. Going down, a triangle is a given vertices. Graph the triangle and classify it by its sides, and then determine if it's a right triangle. Okay, so A is at 3, 1. B is at 3, 4, 2, 3, 4. And this is at 7, 1. 1, 2, 3, 4, 5, 6, 7, up 1, C. Okay. So to do this, this one's a little bit easier. So to decide to classify it by its sides, since I'm on a coordinate grid, I actually have to find the distance or the side lengths to see if any of them are equal. They made this a little bit easier on us because I can see that this hits at a 90-degree angle because this has a slope that is undefined. This has a slope of 0, so they are opposite reciprocal slopes. So this is a right triangle. So this also has a side length of 3 because I can just count it. If I could not count it, then I'd have to use distance formula. And remember, distance formula is big square root y2 minus y1 squared plus x2 minus x1 squared. So you would have to use that distance formula to find the distance. This one I can also count 1, 2, 3, 4. This has a distance of 4. Now, you could use distance formula to find the length of this, or since it's a right triangle, I can use Pythagorean theorem. Does a squared plus b squared equals c squared, my length? So this would be 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. That equals c squared. That is 25 when I add those two together, equals c squared. So I'm going to square root, c equals 5. So we have a 3, 4, and 5 side length. That means that none of them are equal, so this is a scalene triangle. All right. Next one. point at 1, 1 for A, 1, 2, 3, 4, 0 for B, and 8, 5, 7, 8, 1, 2, 3, 4, 5 for C. Okay. So, does not look right. It could be right. These two could be my 90-degree angle. So I'm going to go ahead and find their slope, because if their slopes are opposite reciprocals, then they are right angles. So A to B, the slope is your rise over your run. So I rise 1. I'm just counting. And I run backwards 1, 2, 3. So backwards is a negative. And then I'm going to find BC. I rise 1, 2, 3, 4. I rise 4. And I run forward 1, 2, 3, 4. Is that right? 1, 2, 3, 4. 1, 2, 3, 4. Oh, 5. Sorry. Let me try this again. I rise 1, 2, 3, 4, 5. And I run 4. Sorry about that, guys. These two are not opposite reciprocals. So this is not a right triangle. So not right. Okay. And then classify it by its size. So I would have to find distance formula for each of these. I'm going to find distance formula for AB first. So here's A and here's B. Y2 would be 0 minus 1 squared plus x2, which is 4 minus 1 squared. 0 minus 1 is 1. 1 squared equals 1. 4 minus 1 is 3. 3 squared is 9. So that's 1 plus 9, which is the square root of 10. So AB is the square root of 10. I'm going to pause myself. I'm going to find BC and AC. I want you to also pause, and I want you to find those distances, and then we're going to classify this triangle. Okay, for BC, I got square root of 41, and for AC, I got square root of 65. Hopefully I did the math correct, and if you got a different answer, recheck yourself, and then recheck me, I guess. I left them as square roots because they're all going to give me decimal answers, and so it's just easier to look at them this way to see if they are the same or not. So this is not right, and it is scaling. And this angle actually looks like it's obtuse. It does not look, we know it's not 90 degrees because it's not a right triangle, and it looks like it's more than 90, so it's probably an obtuse scaling triangle. All right, coming down here, find the value of x and classify the triangle by its angles. So we know the three angles always add up to 180. So this would be 90 degrees for this angle, plus x plus 2x equals 180. So that would be 3x's plus 90 equals 180. Subtract 90 from both sides, so I get 3x equals 90. Divide by 3, you get x equals 30. So now I'm going to plug it in. That would make this angle 30, this angle 60, and that angle 90. And then it says classify by its angle. So this is a right triangle because I have a 90-degree angle. Go ahead and pause me and try 7 and 8 on your own, and then unpause me when you're done, and I'm going to pause also. So on number 7, it was 3x's plus 2x's plus 55 equals 180. When you do all the math and solve for x, you get x is 25. If I plug that in, I get 50 degrees, 75 degrees, and 55, which would make that a cube. This one is the exterior angles theorem from the front, where this exterior angle of x is equal to the two non-adjacent interior angles added. So 50 plus 70 would equal that x. So x is 120. Well, this exterior plus this interior make a line, so they equal 180. So that makes this angle 60 degrees. So now I have a 60, 50, and 70, which would make that triangle a cube also. All right, I'm going to do a second video for this page. What I want for you to do before you start that second video is I actually want you to try all of 9 through 20 and see how much of this you can do on your own before going to that video. All right, thanks guys.